Okay, for tonight's video, we'll be reviewing operations on rational expressions. So what you need is just a few sheets of lined paper. We'll be working out 6 problems together, and these problems are actually coming from worksheets that we'll be working on in class tomorrow. So the first worksheet is labeled page 111, and we're doing question number 7, which is a multiplication problem. 25 minus x squared divided by 14 x to the third y to the eighth times 7x squared y divided by 8x plus 40. So when we're asked to multiply two rational expressions, the first thing we're going to do is factor the numerators and denominators. So 25 minus x squared, that's the difference of two perfect squares, 5 plus x times 5 minus x. The monomial in the denominator does not factor, so we just copy it. Our second numerator also has a monomial, so we copy that. And now factor the denominator. 8x plus 40 has a GCF 8, and the other factor is x plus 5. Now, factors that are common to a numerator and denominator can divide out, like the x plus 5 and the 5 plus x. They are the same, just written in a different order, so they divide out. 14 and 7 reduce to 2 and 1. X to the third in the denominator and x squared. The x squared in the numerator divides out with 2 from the x to the third, and it leaves you with a single x. And y to the eighth in the denominator will divide out 1y from the numerator and leave you with y to the seventh. Okay, so now our numerator is simply 5 minus x. Our denominator, we have 2 times 8, which is 16, x, and y to the seventh. So that's our answer. Our next problem is number 9. It's also a multiplication problem. 2x plus 10 divided by 32 minus 8x times x squared minus 10x plus 24 divided by x squared minus x minus 30. Again, it's a multiplication problem, so we're going to look to factor our numerators and denominators. Our first numerator has a GCF of 2, so 2 times x plus 5. The denominator has a GCF 8, 8 times 4 minus x. Our trinomial in our second numerator here, we look for the factors of 24 that add to negative 10, negative 6 and negative 4. So this factors into x minus 6 times x minus 4. The trinomial in the denominator, again, this is a simple factorization of a trinomial because the lead coefficient is 1. So we're looking for the factors of negative 30 that add to negative 1. That would be negative 6 and 5. So x minus 6 times x plus 5. Now that everything's factored, divide out common factors. The x plus 5s divide out, the x minus 6s. The 4 minus x and the x minus 4, these are opposites. So we'll divide them out and replace either one of them with a negative 1. I'll put it up in the numerator here, negative 1. And one last thing, the 2 and the 8 reduce. 2 and the 2 once, 2 and the 8 4 times. So let's look across our numerators. We have 1 times negative 1, that's negative 1. And 4, so negative 1/4 is our answer for that. Our final answer is negative 1/4. Our next problem is a division problem, which would be on page 113, number 5. and it is 12n minus 36 divided by 9 minus n squared. That rational expression divided by 8n to the 5th over n squared plus 3n. Okay, so remember with division, we are going to change to multiplication, so I'll do that, and we're going to write the reciprocal of the fraction that follows. So our denominator now would be 8n to the 5th. I'm going to do this in one step. So n squared plus 3n would be our numerator of our second fraction, but I'm going to write it in factored form. There's a GCF of n times n plus 3. And our first fraction we leave as is, but we do factor it. There's a GCF of 12, so that'd be 12 times n minus 3. And the denominator is the difference of two squares, 3 plus n times 3 minus n. So everything's factored. Divide out common factors. The 3 plus n and the n plus 3 are the same. They divide out. The n minus 3 and 3 minus n, they are opposites. So divide them out and place a -1. I'll put it in the numerator. The 12 and the 8 reduce, dividing each by 4. 4 goes into 12 3 times, 4 into 8 twice. And the n in the numerator will divide out with 1 of the 5 in the denominator, leaving us with n to the 4th in the denominator. Now multiplying across, our numerators, 3 times -1 is -3. And our denominator looks like we have just 2 times n to the 4th. Next problem we're looking at is an addition problem. Page 119, number 7. And we have the rational expression a plus 6 over 4a to the 3rd plus 4a plus 3 over 12a to the 2nd. Now when we're adding fractions, you need a common denominator. All right, so if we look at our denominators, 4a to the 3rd and 12a squared. 12a squared seems larger. Does 4a to the 3rd divide into it evenly? 4 does, and a squared does. We need another a. So our least common denominator here is going to be 12a to the 3rd. So we're going to write down equivalent fractions with denominators of 12a to the 3rd. Okay, so take 4a to the 3rd. What do we need to multiply by to get 12a to the 3rd? Multiply by 3. Do the same to the numerator. Make sure you distribute. So we have 3a plus 18. And 12a squared, what do we need to multiply by to get 12a to the 3rd? We need to multiply by a, so multiply the numerator by a as well. Again, when we're doing this multiplication here, we're actually multiplying by 1 in the form of a over a. So that's not changing our fraction. Multiplying by a, we have 4a squared plus 3a. Okay, we have the same denominator now, so let's copy it, 12a to the 3rd, and then combine like terms of the numerators. There's no other 4a squared term, so 4a squared. We have a 3a and the 3a add to be 6a, and our constant of 18. Now, can this be simplified? Well, let's see. First off, there is a GCF here. So let's take out a GCF. So we have 2 times 2a squared plus 3a plus 9 over 12a to the third. And we have to check, okay, the trinomial, can this be factored? Are there factors of 18 that add to 3? Not a positive 18 that add to 3. If it was negative 18, we could use 6 and negative 3. Okay, so this is factored. Now we'll just divide out the 2 and the 12, reduce. And apologize for this, but I'm going to go this way. And our final answer would be 2a squared plus 3a plus 9 over 6a to the third. We're going to finish up with 2 subtraction problems. And they would be found on a worksheet that is numbered page 121. We're doing number 5 first, which is 5 over x plus 5 subtract 2x plus 5 over x squared plus 9x plus 20. We want to subtract these 2 fractions, so when adding and subtracting you need a common denominator. Let's look at our second denominator here and factor it. The factors of 20 that add to 9 are 4 and 5. So this is x plus 4 times x plus 5. We're writing down equivalent fractions with the same denominator, okay, which is each factor the greatest number of times it appears. So x plus 4 times x plus 5 is our least common denominator. What do we multiply x plus 5 by to get x plus 4 times x plus 5? Yes, x plus 4. 5x plus 20. This is already our denominator, so just bring down the numerator. 2x plus 5. Denominators are the same. Let's copy it. X plus 4 times x plus 5. And remember, we have subtraction, so be careful. Make sure you subtract each term that follows. 5x minus 2x is 3x. 20 minus 5 is 15. And let's see if we can factor the numerator. There's a GCF 3 times x plus 5 over our denominator. And the x plus 5s are common, so they divide out. And our answer is 3 over x plus 4. And the last problem, another subtraction problem. This is numbered 7. And it is 8 over 5d plus 4 subtract 1 over 2d minus 3. We look at these denominators. Neither one is factorable, and they don't have anything in common at all. So the least common denominator here of these 2 fractions would be their product. So 5d plus 4 times 2d minus 3. So we're writing equivalent fractions with denominators of 5d plus 4 and 2d minus 3. All right, we need to multiply by 2d minus 3. Distribute, that's 16d minus 24. And here multiplying by 5d plus 4. (5d plus 4). And again, it's subtraction. Let's copy the denominator, 5d plus 4 times 2d minus 3. We're subtracting, bold that out so we don't forget. 16d minus 5d is 11d. And negative 24 subtract 4 would be negative 28. Can we factor the numerator? No, it's not factorable. So this is our answer. And that concludes tonight's video.